All right, so I'm gonna try to do this as best I can while I'm at home. So basically, you're gonna be solving equations with radicals in them. Everything you already know about solving equations still applies. It's just about using strategies to help eliminate the radical. And something that eliminates the radical is doing the opposite of rooting something is to put it to the opposite exponent. So if you have a square root, you want to do the opposite, which is to square it. Before you even start, if you have a radical in your equation, you need to figure out what your permissible values are or your restrictions. So basically, everything under that radical sign, whatever it is, it cannot be negative because it's a square root. If it has an even index, you cannot have a negative radicand. So that means that 2x minus 1 must be greater than or equal to 0. Okay, so then you solve for x in this inequality. So you're going to add 1 to both sides, and you're going to get 2x has to be greater than or equal to 1. And then you're going to divide both sides by 2, and you're going to get that x has to be greater than or equal to positive 1/2. That is your permissible values. Okay, so when we solve for x, we're going to check our values of x to make sure that they work, right? So now we're going to go to the actual strategy of when you have an equation. So our equation is 5 plus the square root of 2x minus 1 equals 12. So what we want to do is we want to isolate the entire radical. So this whole thing here, we want it by itself. So we're just like algebra, as if it was its own thing, we're going to move everything else away from it using opposite operations and working in the opposite order of bed mass. So we're going to deal with that 5 first. So we're going to subtract 5 from both sides. And then we get the square root of 2x minus 1 equals 7. We've now finished step 2, which is to isolate the radical. Our radical is now all by itself on one of the sides of that equals symbol. The next thing we're going to do, step 3, is we're going to square both sides. We're going to square the entire side, okay? So we're going to square both sides. The opposite of square rooting something is to square it. So the square root of 2x minus 1 squared is just everything that's inside that radical, which is 2x minus 1. 7 squared is 49. So then you're going to add, so that's, you've squared both sides, you've eliminated your radical, and now you just have an algebraic equation that you need to solve using your skills of algebra, again, working in the opposite order of BEDMAS to work backwards to figure out what x could possibly equal. So the first thing, we have 2 being multiplied with x and then 1 being subtracted. So of course, in opposite order of operations, working backwards. For algebra, we're going to add 1 to both sides first. So we get that 2x equals 50, and then we're going to divide both sides by the 2, and we get that x equals 25. Okay, so that is our solution, is x equals 25. The first thing we're going to do is not stop there. We're going to check against our permissible value. So we said that x had to be greater than or equal to 1/2, right? That was what we decided up here because of what was under the radicand. Is 25 more than or equal to 1/2? Yes, it is. So we go on to the next step. If it wasn't, we would discard the solution. And if it was our only solution, we would say there is no solution for this radical. All right, so the next thing we do is we check for extraneous roots. This generally happens when you have a negative square root in your equation, which is not the case here, but we're still going to go through and double check. So even after you check with your permissible values, you still might have a solution that doesn't actually work. So you need to verify your solution. So it's 5 plus the square root of 2x minus 1 equals 7, I believe. I just can't really see it off the screen here. Nope, it's equals to 12. 12. Okay, so now we're going to put in that solution of 25 in for x and see, does it actually work? So it's going to be 5 plus the square root of 2 times 25 minus 1 equals 12. So 5 plus the square root, 25 times 2 is 50, 50 minus 1 is 49. The square root of 49 is 7. Does my left side equal my right side? Yes, it does. So that means that x does in fact equal 25, and that is our solution. And I'm going to stop the recording here.